So, good morning and good afternoon, and welcome to the first appointment of this week to Sumbijay Academy, logging in reservoir monitoring. Today we are talking about and focusing on a special technique that is Reservoir Saturation Tool, RST. The RST Pro Reservoir Saturation Tools incorporate a pulsar neutron generator and dual detector spectrometry system to measure elemental concentration, including carbon and oxygen, and formation neutron capture, cross section sigma. Oil volume is during a signal trip in the well. Oil volume is computed from the carbon-oxygen ratio, CO, determined through spectral analysis to eliminate any environmental bias. The accuracy of the resulting reserve estimated is comparable to that from core analysis. The sigma measurement is used to determine porosity and differentiates between saline water and oil to calculate formation oil saturation. Where formation water is fresh or now salinity, saturation is determined from the CO ratio measurements, which is salinity independent. A quantitative mineral-based lithology by putting the elements yield measured by RCT2 pole spectral lithology. It's clear that production logging application, for example, there is a versatile application for tools that provide answer during logging during reservoir monitoring. It is especially for advance and optimization of production and to monitoring the volume of reservoir. The TPHL free phase workout method. The tool is continuous measurement and of all the ops oil, water and gas for wells at any deviation. The F-well water's flow made by this kind of tool is conducted to located and evaluated axial water migration behind pipe, measure to the velocity of water flow in wells and determine the time the internal or behind pipe close flow between zone. The PLV phase log velocity made RC tools measure and make elements that is solvable only to calculate the velocity of that phase in deviated well. It is just an application for the not vertical well, but for the deviated well. And the principal parameters that analyze in reservoir saturation is not only carbon dioxide ratio, but also the water flow log and water flow log, and make also the gas water flow logs. So we have an answer of evaluation for example, for sigma and gas sat logging option used for formation saturation, rapid data evaluation supported by on-site data processing, and your global teams and like this. So we have also the gamma this kind of value. The change in reservoir lithology and fluid properties will create different response from reservoir saturation log. A key aspect of Exp reservoir saturation tools. This tool characterizes answer to the tool's response is recognized for the specific condition to be anchored the landing the more the diagnosis. It's clear that also a great application and great work for petrophysics, and there is an example of how we can study the different phase, water, gas, and oil zone. There is this phase underlying the water zone, the hydrocarbon zone. Another factor generally that we analyze is the variation on total porosity and pressure during the first phase of extraction and during the whole reservoir monitoring. How, for example, the total porosity in reservoir change along the P cable installed, but also is important to make a decision for when, for example, starting electrical fracturing or other stimulation activity. And also is important for establish, for example, not the variation of pressure. So the variation of pressure is really essential to a long life of reservoir, because if pressure remain constant, there is also a more aqueous porosity that can be used, for example, to the flow gas or other like this. So what around the typical results of these kinds of logs is the three types: delta SFU, water saturation, and sigma V. We have also starting developing a web application based on Python that is still with simulated data, baseline sigma V and SSV. But it's really important to understand that during the reservoir monitoring, this kind of operation is really essential to the maintenance and the long life of reservoir, because the change in pressure, for example, forced to extract a really high volume of gas can be close the pore or change the volume of make, for example, a subsidence phenomenon when we have a cup made with sandstone or claystone. So it's really interesting, and then we make a next appointment to other kinds of techniques using reservoir monitoring.